All right, we will get to the new notes in a second. I just wanted to make one note. Someone mentioned to me yesterday that I did make a mistake in my notes. So if you go back and look at it, or if you questioned it yourself at the time, um, from this page in the notes from yesterday, looking at number 3, the measure of angle, or sorry, the measure of arc UTS. Measure of arc UTS should actually be 50 plus 40, which is 90. It is still a minor arc, but it's 90 degrees, not 140. Just a quick reference, I think what I did was I think that I found the measure of UTR, and UTR is 140, but I'm not 100% sure. All I know is that I was wrong. Right? So again, number 3 there should be 90 degrees. That is still a minor arc. All right, we are looking at 10.3 today. That's arcs and chords. And we've got a couple of theorems to look at here to start with, though most of them end up being, I think, pretty straightforward today. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So this is if chord segment FG and JH are congruent, then the arc FG and the arc JH are congruent. If arc FG is congruent to arc JH, then the 2 chords are congruent. I'm not sure what's happening here. Ignore the extra bar there. I did copy this off of the book, and apparently the book has it in there as well. So it should just be the arc, not with a segment over it. The only thing that's kind of important here is this second, most of it's straightforward, or in congruent circles. If 2 circles are congruent, this is also true. It still works. If a diameter or radius of a circle is perpendicular to a chord, then it bisects that chord and its arc. So here we have a diameter. We know that AB is a diameter because it goes through the center and goes to each side of the circle. So that means that it must be bisecting, meaning XZ and ZY are congruent, and also the arc XB and the arc BY are congruent. That would also, again, be true if it was just a radius. It doesn't have to be the whole diameter for that to work. I suppose, simply put, just to kind of give a brief proof for it, because it's not too difficult, we can get this set up very quickly. If we had those 2 radii drawn in, right, and we know that this is perpendicular, then those 2 parts have to be congruent because they are radii and radii are congruent, and then in the same circle are congruent. And then we have a C is equidistant to the endpoints, meaning that it's on the perpendicular bisector and it's perpendicular, so these 2 parts have to be congruent. The other part would take a little bit more work, but think about it as the angle bisector here then, right? And then you have a central angle and another central angle, and since the measures are going to be the same, then the arcs that they include have to be the same. Okay. The perpendicular bisector of a chord is a diameter of the circle. So this is just basically the converse of the last one, right? If it is the perpendicular bisector, if it is the perpendicular bisector, then it must be a diameter or radius. There's not a different one that also does that. In the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. So if you have two congruent chords, then the segment that goes to that chord that is perpendicular to that chord from the center must be equal to any other chord that's equal to it doing the same thing. Again, if I'm moving too fast through the theorems for you to write, just press pause. Find the value of x in each circle. So for number 1, we have two different chords in the same circle. They are both have a measure of 13, which means they are congruent, which means that the arcs WV and TU must also be congruent. And since TU is 79, X must be 79. The quick note there, you do not need degrees on that because it says X degrees. It's a little bit tough to see. So this is 79. We don't need the degrees there. I'm not going to do that for all of these. PQ and RS are congruent. They have the same length in the same circle, so two chords, same length. That means that their arcs are also equal. 4x plus 2 is equal to x plus 17. Subtracting x, we get 3x plus 2 is 17. 3x is 15. Divide both sides by 3. And x is 5. All it asks us to do is find the value of x. Just note, in a different problem, it could ask for the measure of PQ, right? It could ask for the measure of RS. And then you just be filling 5 back in. All right. Here we're going the opposite way. We have two chords. We don't know initially if those two chords are congruent, but the arcs that they hold are both congruent. And by one of our theorems, that means that the chords must also be congruent and have the same length. So 2x minus 12 must equal 36. Add 12 to both sides. We get 2x is 48. And x is 24. All right, you'll notice that the next one is a little bit trickier, or at least it looks a little bit trickier, in that we don't have a whole lot of information, right? But what we do know is that ST and SU have the congruent chords, which means that their arcs must be congruent. So the arc ST is X. That means that the arc SU must also be X. Now, some of you may figure out right away what you're supposed to do with that, but some of you may not, right? So what do we know about a circle, or the measure around a circle, right? So the measure around a circle is 360. We know that based on the central angles being summing to 360, right? And since the central angles sum to 360, the measure around the circle must be 360 as well. And we have all of the parts here. We have x, and x, and 38. That is all of the measure around the circle, which is 360. We add the two x's together and subtract 38. 330, 322. So x is 161. Take a look at 5 and 6 here and see if you can figure them out on your own. Number 5 is relatively similar to our last one. And then number 6 is kind of putting like 2 or 3 things together. So pause and try to take a look at those ones. But I'm going to just continue. So this one, like the last one, we have 2 congruent chords. Those chords lead to congruent arcs. So we have x plus 114 is 360. Again, it's the distance around the circle is 360. So the biggest mistake I could see you making here is trying to set like x to 114 or 2x equaling 114. Just remember that if you're going all the way around a circle has 360 degrees. So the sum of the arcs must be 360, right? So if 2x, subtract 114 from both sides, let's see, 56, 46, and 2. And we get 123. As long as I added and subtracted correctly. I think I did. Number 6, we have congruent chords, MP and RQ, segments MP and segment RQ. Because they are congruent, the arcs that they hold are congruent as well. And we get 67 degrees there. And then what we get is that from yesterday, this angle here, which x is, comes from the center of the circle. So it is called a central angle. The central angle of a circle is equal to the arc that it holds. It holds the arc RQ, and RQ is 67, so x is 67. In circle Y, the radius is 34, AB is 60, and the measure of arc AC is 71. Find each measure. So for the first time, I am thinking about this. What you might do is pause the video until you get at least the circle drawn and the information written. You might have time because I'm talking about it right now. But in general, I probably don't leave enough time for that, which is good just then to pause the video and wait. So with the diagram, I think the diagram is important. We know that arc AC is 71. YC is a radius, right? It is perpendicular to a chord, which means it must be doing 2 things. 1, bisecting the chord, and 2, bisecting the arc. So since the arc is 71, each of the parts here have to be 35.5. Okay? And since AB is 60, AD and DB must each be 30. And let's see what we can do with that information first. Arc BC is 35.5 degrees. I'm sorry. Completely wrong. Read the directions. I'm right, but I'm wrong on something else. So I thought it said the measure of arc AB. This is a mistake I could make in class 2, right? Unfortunately, there's nobody here to correct me today, So hopefully as much as possible I make the corrections myself. But if I do make a mistake, please let me know and I'll correct it tomorrow or the next day or Monday. So AC is 71, right? So BC is 71. That actually makes more sense in what our diagram looks like. So BC is 71. So again there, just to go back, I thought wrongly that it was saying AB was 71 and that then AC and BC were each half of that. However, that got cleared up here. Going back and looking at AB, AB is 142. AD we have marked, it is 30. It is 30. Again, this time I don't think I made a mistake. The segment, the chord, AB is 60, and AD and DB have to be half each, right? BD is also 30. And then I think we get into some interesting stuff. Let's see if I'm right. YD and DC. So your first thought, which is wrong, is to say that YC is being bisected, and since the radius is 34, YD must be 17, and DC must also be 17. However, nowhere do we have something that says that, right? In fact, I can probably quickly show you why that logic doesn't make a lot of sense. So I'm going to try to put it in the diagram why it wouldn't make sense to say that YC is being bisected if this is true, right? There's nothing that says that this isn't the chord that we're talking about, right? This chord is also being bisected, and we don't know any more information, right? Or this chord, right, could be perpendicular, but you wouldn't make the assumption that if it were drawn this way, you wouldn't, I don't think, make the assumption that this chord is bisecting YC, right? But again, there's no other information that's given than what it's giving here. So basically, we should be thinking about those two chords the same way. So I know that was probably a little bit, maybe a little bit confusing. What you need to know, what you need to pull off here is that nowhere does it tell us D is the midpoint of YC. It doesn't give us any information that would lead us to believe that, except for that it looks like it in the diagram. Or it looks a little bit like it in the diagram. So here's what we're going to do instead. We know that this is a right angle. We know that, not even the one that I want to do, YD, that's fine. Yeah. We know that AY has a measure of 34. It's 34 because AY is a radius, right? It's not the radius they gave us, but it is still a radius. And AD, we already said, was 30. Well, interestingly enough, right, we have a right triangle. This is ADY, right, just pulling it out of our diagram. AD is 30, AY is 34. Well, all of us should be able to find what YD is now, right? Well, it's 34 squared minus 30 squared, and then we need to take the square root of that. And the square root of that, which is 16. So YD is actually 16. And DC, well, we could set it up the same way, or try to. Be a little bit more difficult, probably. Instead, if YD is 16, let's just extend our line here, right? If it's 16, and we know the distance here is 34, right? What would the last side have to be, or that last part? Well, it has to be 18, because 18 plus 16 is 34, right? So this has to be 18, 16. That gives us our radius of 34 like we had in the directions. Homework is on page 719. It's numbers 7 to 14, 22, 31, and 44. Just a reminder, I will be on Zoom today. You can find the information, log in for that on the instructions page for today's work. And yeah, if you don't know what that is, that's a live conferencing site. You can answer your questions for homework, or if you have questions over the notes or anything like that, we can get on and do that.